Okay, so this is a good calculus problem, assuming you're in Calc 3 doing this. So what you want to do is you want to find the arc length, and then later on, after doing that, you want to find where we are on the curve if we travel a distance of 20. Okay, so let's write out the formula for arc length. Well, we know the length is S, and then it's going to be, the length is L, integrating from b to a in the norm of r prime of t dt. Okay. Now notice we don't have bounds, so for us it'll just be from b will be just t and a will be 0. Okay, so but first let's find r prime of t. Let's take the derivative of this, but with respect to time. So we're going to get 2t, and then we're going to get 6t squared, and we're going to get negative 3t squared. Okay. So now if we want r prime of t, its norm, that means we got to square root everything and square everything inside too as well. Okay, so 2t squared, then we get plus 6t squared, and plus negative, let me make that look a little bit nicer, negative 3t squared. Right. So we're going to get 4t squared plus 36t to the fourth, and then we're going to get 9t to the fourth. Okay. So I'm going to write over here now, and we're going to try to simplify this as much as we can. So we're going to group these guys together. 36 plus 9, that's 45. So we have 4t squared plus 45t to the fourth. And then we could factor out a, what can we do? We can factor out a t squared here. So if we factor out a t squared, it'll be like this. Right. And we'll get 4 plus 49 t squared. Not 49, 45, my bad. And then we would just get t 4 plus 45 t squared. So this is our integrand. Okay. And what we want to do is we're going to integrate from t to 0. And I'm not going to call it t just for the sake of, I'll do it, whatever. T to 0, t, and 4t squared. No, 4 plus 45 t squared dt. Okay. So if we do this, we're going to have to make a substitution. We'll do u is equal to 4 plus 45t squared. Then we see that du is going to be 90t dt. And then if we're going from t to u, and our bounds were t and 0, then u, okay, so as you can see it's strong because I did the problem and then I explained it kind of poorly, so I'm going to redo it from here. So your bound for t, right, is t to 0. Now your bound for u, this will be your first bound for u. So it's going to be 4 plus 45 t squared. And then think about this, right? So if you put 0 in here, that's just going to be 4. Okay. Now that's tiny, but it's going to be a bit bigger in a second. So now your new integral is going to be from 4 plus 45 t squared to 4. And your new integrand is going to be t squared u. And then let me write what dt is here. So dt is going to equal to du divided by 90t. So now we're going to have du 90t. Okay, then we can see that the t's will go away. And then we're just going to be integrating square root u, which is u to the 3 halves, divided by 3 halves, and then we got 1 over 90 here. And this is being integrated from 4 plus 45 t squared to 4. Okay, my screen's not updating. There we go. Okay, so 1 divided by 90 And then this is 3. This is 2 over 3, since it's under, right? So we take the reciprocal of this. It's 2 over 3. So 2 times 3 times 90. 2 times 270. 2 over 270 is 135. 1 over 135. And then u, now we're going to insert this into here. We're going to get 4 plus 45 t squared 3/2. And then the other one will get 4 3/2, which I believe is the same thing, real quick. So I'll do it 4, that's the same thing, and then that's 4 times 2, which is 8. Okay, so I'll clean this up in a second. This will be 1 over 135, and then we'll have 4 plus 45 t squared 3 over 2 minus 8. Okay, so this is your first answer. This is your answer for number 3. This tells you the arc length as a function of time. Okay, so like let's just say for 2 seconds in, then this is the distance you will be along the arc. However, for question 5, it wants to know the opposite. So we're given the same curve, but it's asking to determine where on the curve we are after traveling a distance of 20. So it kind of wants to do the reverse, like I said. Okay, so remember how earlier we said length is equal to t to 0 r prime of t dt? Well, what if you want to know the distance? Like, okay, let me say this better. Okay, I figured out a way to say this better. So let's say you want to know, like, okay, this tells you your distance as a function of time. But what if you want to know your time as a function of distance? Okay, so with this relationship, what we can do is we can use the fact that length is equal to 1 over 135 and 4 plus 45 t squared 3/2 minus 8. So we can use that relationship, right? That's what we have. But then we want to know what t is. So all we're going to do is isolate for t. That's it. So we're going to have 135 L and then plus 8, right? And then that is equal to 4 plus 45 t squared 3/2. Okay, so then if you want to go a step farther now, you want this to go away. So you can do 135 L plus 8 to the 2/3 power. And then that is equal to this. But let's go a step farther. So let's minus the 4. And then let's divide by 45. And then now let's square everything. There you go. Let me erase this little arrow right here. Now you have your time as a function of the arc length. So this is important. This tells you, like, hey, I've been traveling for this long, and then there. But the question is not actually done yet. Where are we? Like, what's the time when we've been traveling for 20 feet along the arc? So what we can do is now we can put 20 into here. So if we put 20 in there, we're going to get 135 times 20. All right, just imagine that there's 20 there, and I'm going to show you in the calculator. Okay, so if you put 20 into here, right, if L is equal to 20, then this is the time it takes to get there. Okay, we got one more thing we want to do. Okay, now we're going to read the question. Determine where on the curve. Now this is the curve, right? So we know on the arc, the length is 20, and it takes us 2.05 seconds to get there. But we're on the curve. Okay, so what we do is we're going to do R of. So we found the time, right? We found this time. Now we're going to do R of t. We're going to use R of t, but the t is going to be R of 2.056. So what we're going to do is we're going to put 2.056 into this vector. So it's going to be 2.056 squared plus, not plus, comma 2 times 2.056 cubed plus, not plus, why do I keep saying plus, comma 1 minus 2.056 cubed in bracket. Okay, so this will be your answer for this is your true answer. Like there's a lot of little mini answers in this. Okay. And then I'll give you the exact values of this R of 2.506 in a second. I just need to put it on the calculator. Okay, so if you put this stuff in the calculator, this is what you'll get, right? And the units for this should be called meters. We'll assume it's meters. And this unit for this is seconds. So this is kind of a cool problem. This is why we use vectors, right? We use arc length and vectors. There's a lot of things you can do with this stuff, so it's really cool.